So for this lesson, you're going to need your Unit 5 packet. Please turn your Unit 5 packet to 5G, and we're going to work through 5G during this lesson and learn through 3 new theorems. So please, if you need to stop the video to get your packet, if you have it, then turn to 5G. And the first slide on 5G looks like this. Now, the first 2 slides we did in class today, the ones that start with 8.1 and 8.3. So we're going to start with the slide that says side splitter theorem. So for this theorem, it says that if you have a line parallel to one side of a triangle and intersects the other 2 sides, then it divides the 2 sides proportionally. So if we look at this triangle, BD is parallel to AE because it has the lines. And we know by this theorem that it divides the sides proportionally, which means that the ratio of the left side of this triangle has to be equal to the ratio of the right side. So to write that, we're going to say CB over BA, that's the ratio of the left side, has to equal CD over DE. So that's what the side splitter theorem says. So we're going to try these 2 examples using this theorem. And so this should say find the value of x. So for this, we have a triangle, and SU is parallel to RV. So that means we can use the side splitter theorem. So for this, we're going to say that the ratio of x over 16 has to be equal to 5 over 10 because they have to be proportional. Now this one you can do in your head if you know that to get the ratio of 5 to 10 is 1/2. So we need x to be a number so that the ratio of x to 16 is 1/2. And so a lot of you can probably do that in your head and figure out it's 8. But if not, you can always solve a proportion by cross multiplying. So remember, when we cross multiply, we multiply the 16 times 5 and then the x times 10, and then we set them equal to each other. So 16 times 5 is 80, equal to 10x, and then if we solve for x by dividing by 10, we get x to equal 8. And you can always check your answer by plugging it back in. So 8 over 16, if you reduce that, that's 1/2, and 5 over 10 is 1/2. So that means the sides are proportional because they have the same ratio. So for the second example, we have a triangle and this segment. Now they didn't put the arrows to show they're parallel, but we have these 2 90-degree angles. And since these angles are on the same position on these 2 lines, they're corresponding angles. And we know if corresponding angles are congruent, the sides are parallel. So we can mark the sides parallel. And now that we know it, that we can use our side splitter theorem. So we're going to make our proportion again. We're going to say x over x plus 1.5 over x. That ratio has to be the same as 5 over 2.5. So this one is a little bit harder to figure out in your head. So as a result, we're going to cross multiply in order to find our answer. So when we cross multiply, we have 2.5 times the quantity x plus 1.5, we have to multiply it by both parts, is equal to 5x. And then we need to distribute the 2.5 because we're multiplying it by both terms. So we have 2.5x plus, and then we need to multiply 2.5 times 1.5, and that gives us 3.75. And after that point, we just solve an equation. So we're going to get all the x's on one side, so I'm going to subtract 2.5, and that gives me 2.5x. And then I'm going to divide 3.75 by 2.5. And I get x to be 1.5. Okay, so we have x equals 1.5. And again, we could check it. If we plug 1.5 into here, we would get 3, and then x would be 1.5. And then if we check 3 divided by 1.5 is 2, and 5 divided by 2.5 is also 2. So the ratio of both sides is equal and the sides are proportional. So a second part of the side splitter theorem is when we just have parallel lines instead of triangles. So in this case, if we have at least 3 parallel lines and they're intersected by 2 transversals, then the segments intercepted, that these segments on the transversals are proportional. So that's saying that A over B, that ratio has to be the same as C over D. That's what it means when it says the segments intercepted on the transversals are proportional. So here are 2 examples for that side splitter theorem. If we look at this, we have 3 parallel lines of arrows, and then we have actually 3 transversals on this one. And we want to find the values of the variables. So we can set up our proportion, and it says that the 2 parts on the one transversal have to have the same ratio as the 2 parts on the other transversal. So if we set that up, we're going to say 16.5 over y has to give me the same ratio as 15 over 26. And then we can cross multiply these again, so we're going to have 15 times y and then we're going to do 16.5 times 26, which is 429. And then we're going to solve for y by dividing by 15. So then y is 28.6. And we're going to use the same idea to find x. So if we look, x and 30 are on one transversal, 15 and 26 are on the other, so they have to be proportional. So x over 30 has to equal 15 over 26. And then we're going to cross multiply. So I have 26x is equal to 15 times 30, which gives us 450. And then we divide by 26. And x is going to be, in this case, a decimal. We'll round to the nearest tenths place, so we're going to write 17.3. So here we have a sailboat, and we have the parts of the sailboat are broken up into different colors, and we have the length of each part. So when we look at this, we're going to say that these sides are parallel. These lines are parallel, and we want to find x and y. So if we look at this, we have a triangle and 2 parallel segments, which means that the 2 segments on the left are proportional to the 2 segments on the right. So we can figure this out just by looking, because if 1.7 is the top segment and 1.7 is the bottom segment, since they're the same, the 2 left segments have to be the same as well. So x has to be 2 feet. And again, you can set up a proportion if you want. You can just say 2 over x. 2 over x is equal to 1.7 over 1.7, and then cross multiply, and you will still get x to be 2. Then we also need to find y. So if we look, we have 3 parallel lines and 2 transversals for this. And again, the sides have to be proportional. So that means 3 over 2 has to equal y over 1.7, and then we're going to cross multiply. So we have 2y, 2 times y, is equal to 3 times 1.7, which is 5.1, and then we'll divide by 2 to solve for y. So y is 2.55. And then again, you can always plug it back in to make sure it's right. So if I plug 2.55 in for y and divide by 1.7, I get 1.5, and 3 divided by 2 is 1.5. So we set it up and solved it correctly. Okay, the third and last theorem that we're doing is called the triangle angle bisector theorem. So it says if a ray bisects an angle on a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. So what that means in this triangle, AD, this segment here, hard to draw a straight line, but AD here that segment, it bisects the angle because we can see the 2 parts of the angle are congruent. Then it's saying that it divides the bottom side of this triangle. so that it's proportional to the two other sides. So what that's saying, that BD over DC, those are the two segments that the angle bisector splits, is equal to BA over AC. Now, when we do these, the order doesn't matter except for that you have to be very careful that BD, this part of, is always across from AC. So if you want to look at this, if I'm looking at segment BD, how you know what to do is the one that has to be across from it is the segment that's not touching it. So if we look at this, the other segments on this triangle are DC, AB, and AC. And if we look at BD, it does not touch segment AC, but it touches DC and BA. So the ones that do not touch have to be across from each other. And the same thing, BA and DC are also two segments on this triangle that are not touching, so they have to be on the diagonal. Those are the ones we have to multiply together. So as long as you remember that, you'll set up the proportion correctly. So for these two examples, we want to find the value of x. And they said this whole thing is 6, and this piece is x. So to use the triangle bisector theorem, we need the two pieces. So we need to call this piece something. So if we know the whole thing is 6 and part of it is x, this piece is going to be 6 minus x. And the reason for that is whatever x is, like if x was 3, to find the other piece, we would do 6 minus 3. If x was 4, we would do 6 minus 4 to find that. So this piece we're going to call 6 minus x. And now we're going to set up a proportion. So we said we're going to put the two parts of the triangle that are created by the angle bisector, which is x and 6 minus x. We're going to make a ratio of that, and that has to be equal to the ratio of the sides. Now, the segment of x is not touching the 4, so the 4 has to be across from it, which means the 6 has to be on top. And then we cross multiply to solve. So I'm going to do 4 times x is equal to 6 times the quantity of 6 minus x. And then again, you have to distribute and solve for x. So we distribute the 6. We get all the x's on one side by adding the 6x, so we get 10x is equal to 36. And then we divide 36 by 10, which is 3.6. Okay. And again, remember, you can always plug it back in to check it. So if I do 6 minus 3.6 for this bottom part, I get 2.4 if I plug it back in, and I get 3.6 on top. And then I'm going to divide 3.6 by 2.4 and divide and make sure it's the same as 6/4. So that gives me 1.5, and 6 over 4 is also 1.5. So we did that correctly. Okay, so for the second example, we have an angle bisector. We need to find the value of x. So again, we need the two parts of this triangle. That we need these two parts down here, this one and the one that x is on, in order to find the value of x and use the angle bisector theorem. So if the whole thing is 10, we're going to call this 10 minus x for the same reason that we did on the last problem. And then we're going to set up our proportion. So 10 minus x over x is equal to 6 over 8. So the ratio of the two parts that the angle bisector creates is equal to the ratio of the two other sides of the triangle. And again, this x and 6 part are two segments that are not touching, so they have to be across from each other to check yourself. So then we cross multiply. I have 6x is equal to 8 times 10 minus x. We're going to distribute the 8, so we have 6x is equal to 80 minus 8x. We can add the 8x, so we get 14x is equal to 80. And 80 divided by 14 gives us x equals, we'll round it to the nearest tenths again, 5.7. Okay, so for your homework, there are a few more slides with examples on, and I want you to try those slides, and then come back to class with questions, but I want to do one more slide before we're done. And so if you turn in your packet to see this slide where it says complete the proportion, it's the last page of G. We want to fill in the missing part for this proportion. So if we look at this, we have a triangle and we have 3 parallel lines. So we're going to use the side splitter theorem, or the angle bisector theorem, because we also have a triangle and this is an angle bisector. So if we look at it, we have RS over something is equal to JR over KJ. So if we look at that, this KJS is a triangle, and we have an angle bisector, so we're going to use the angle bisector theorem. And so if we look at this, the part that we're missing in the triangle, we have RS, which is this piece, we have JR, and we have KJ. So the last piece that we're missing is KS for the angle bisector theorem. So we're going to put KS there. On the second one, we have QL. So if we highlight that, we have QL, which is this whole side of the triangle from here, to here. QL is right there. We have PM, which is these 2 parts. And then we have SQ, and so we have 3 parallel lines are transversal, so we're using the side splitter theorem. So we know that QL over PM has to be equal to SQ, and we have to find out what's the corresponding part to SQ, and that would be JP if we look across. So we're going to put JP here. Okay, so we're just filling in the missing piece of the proportion. So on the next one, we'll do one more, and then you can try the last 2 on here, and the other one's on the next slide. So on here, we have KP, which is this. Then we have LQ, which is down here. And then we have QK, which is this segment. So if we look, we have our triangle and our parallel sides, so we have to figure out what part are we missing on this proportion, and the part that corresponds to LQ. So if we look on the other side, the part that corresponds to LQ is PM. So we're going to write P to M. And if you write MP, that's fine as well. The order does not matter, just the segment does. So for the rest of your homework, I want you to complete 5G, and then we'll go over that in class next time.